Changing. One more time.
Okay, hello, my name is Steve Broy. I'm the Director of Engineering over at Teledyne Analytical Instruments. I'm here in our factory in the City of Industry, right outside of Los Angeles, California. And I'm going to take you on a quick training video here for our Model 3020. This is an example or a replica of the Model 3020. In this case, it's a 3020P, which means it's a percent analyzer. We also make a similar analyzer, which looks the same on the outside, which we call the 3020T, which is for measuring trace oxygen. So we're going to go briefly through what the unit looks like inside, theory of operation of the sensor, basic operation of the unit, calibration of the unit, and routine maintenance. Okay, first of all, this is the unit. The controls are mounted on the outside. As you can see, all of the controls, there is two displays. One display is an LED display here, which shows the percent oxygen. In this case, we're reading 0.06% oxygen. This is a vacuum fluorescent display that shows you how to get through the menus of the unit to configure the auto calibration timing, alarm set points, things of this nature. Calibration, gas value, etc., etc. So first of all, let's take a look inside this unit. Again, both the 3020P and T have identical construction with the exception of the sensor. This is the motherboard, the computer board of the unit that it contains a microcontroller. This is the preamp board that processes the sensor's output signal, which in this case is a current, and converts that to an oxygen reading, which we then show on the display. This is the power supply board and interconnection board, and here this is particular interest for our customers' technicians, because this is where you will make your connections to your process control system. So there's an input for remote span if you want to tell the unit to go into a span mode remotely. There's also a remote zero. Now for percent analyzers, you never need to zero them, so you would never do that for a 3020P. For a 3020T, it's the same thing. There's no need to zero the unit. In most cases. The reason we have a zero there is because the sensor, when it's exposed to pure nitrogen, will come down to a level that is typically about 100 parts per billion. So for customers, for that error is important, you can remove that error by doing a zero cycle. Some sensors will come down to 100 parts per billion, some to 200, some to 50, so there's variation there. But generally speaking, 99% of our customers for these units don't need to zero them. We also have programmable alarms, two alarms, alarm 1 and alarm 2, which are shown here to connect to. They can be configured as fail-safe, non-fail-safe, latching, and non-latching, as shown on the silk screen. There's also a system failure alarm that can be configured the same way. There's a calibration contact, which is a relay contact that you can connect to your process control computer that will tell you if you're in the calibration mode or not. We have 4 range identification contacts to tell your computer which operating range the unit is on. This unit has 3 user programmable ranges. In this case, you can program any one of the 3 ranges to any range between 1 and 25%. So, for instance, you could set a range at 25%, another range at, say, 10%, and another range at 1%. You also have the range 4, which is a calibration range, which is always 25%. We have a network connection that's not used in this unit, so there will be no opportunity for network connection, but there is RS-232 connection, which one can make a connection to if one wants to. Then we have, if you want to, you can connect external solenoid valves for auto calibration, and these are the connections for them. And here's the connections for RS-232 if you wanted to connect it to a PC. Very few of our customers use this, but it is there. If you want to connect a sensor remotely, in some of our units, the sensor, instead of being inside the housing, inside the explosion-proof housing, is mounted remotely, and there's 4 wires that come from that type of setup, 2 of which for the sensor, the other is for the temperature compensating thermistor inside of the sensor block. Also, most importantly, we have two analog outputs in voltage, 0 to 1 volts, two 0 to 1 volt signals, one of which tells you the percent of range. So for instance, if you were working on a 0 to 10% range and you had a reading of 5%, then you'd have a half a volt on your percent of range indicator. Also, we have a 4 to 20 milliampere that gives you a percent of range indicator also. So for sake of example, again, if you're on a 10% range with a 5% reading on the display, then the current you should get would be 12 milliamps, I believe. Is that correct? 12
That's correct,
milliamps?
that's correct.
Okay. Did my math correctly this time. And these are the explosion-proof switches. Now, of course, if you're operating this in a hazardous area, I'm sure all of you know that all the bolts must be installed for it to be fully operable. Do not try to just get by on one bolt. And if you need to open the unit, the area will need to be declassified temporarily. Okay? So that's the basic setup of the unit. Now the first thing we're going to handle is sensor installation. Okay, these units come with a sensor that is in a separate bag. And so the first thing you're going to want to do, in this case the sensor's installed. But let's walk briefly through sensor installation because this is the first thing you're going to need to do once you get this unit all wired up, powered on AC. Oh, one thing I forgot to mention, those are the AC terminals there. The universal power supply, 115, 230 volts AC. Make sure that's connected properly. Anyway, you get a sensor, it's going to come in a small bag. If it's a 3020T, you're going to get a sensor that's probably either an A2C, a B2C, or an L2C. That type of sensor doesn't like being exposed to air very long. So what you want to do is purge the unit with either nitrogen or your process gas, get it out of the bag immediately, cut the bag open, and get it inside the sensor holder as soon as you can and under purge. Now keep in mind the sensor has gold contacts on it. That needs to be facing toward the contact pins in the cell holder, okay? And this is the sensing surface. This is where the oxygen comes in and reacts with the sensor's chemicals and structure to provide the output signal. So get this sensor out of the bag quickly, put it in there, screw the cap in. If it's that type of unit, if it's a 3020T, there'll be a latching mechanism that you put it in. In any event, put the sensor in. It's very simple, and this type of sensor will last anywhere from 6 months to 1 year in service. Oh yeah, good point. My colleague who's helping me film reminded me of a very critical point, which is when you get these sensors out of the bag, there will be a small button here. That's designed to short the output of the sensor while it's being transported. Before you put the sensor in the unit, remove that shorting clip. Get a small pliers or pull it off with your finger or whatever. It comes off fairly simply. Do not put the sensor into the unit with the shorting clip on there. You'll damage the sensor and the unit possibly. Okay, so thank you for reminding me that. We put this in and again, screw it in, install it, and there you go. It's that simple. Now you'll have to replace that sensor occasionally. So the first step after sensor installation is calibration, generally speaking. For a trace sensor, the sensor needs to be installed and purged with nitrogen or process gas. We would recommend for typically 24 hours, unless you're using the InstaTrace option, which allows the sensor to come down very quickly, typically within an hour. You can calibrate after about an hour with the InstaTrace. If you don't have the InstaTrace option, purge that sensor for about a day to bring it down low, and then we recommend calibrating typically on 80 ppm or 8 ppm gas, if it's a trace analyzer. If it's a percent analyzer like this, you can typically calibrate that within an hour of installation or less. And for percent analyzer, which this is, it's very convenient to calibrate it on air. So right now we have the unit on nitrogen, as you can see. What we're going to do now briefly is put the unit, switch this valve to put air in there. And you'll see it responds upscale very quickly. Make sure you've got flow through the unit, of course. The unit is pretty much flow insensitive, but you want to keep a constant flow if you can, typically of about 1 standard liter per minute or so, but anywhere in there is okay. And one neat thing about the micro fuel cell technology, which these units use, is the sensors are flow insensitive. So if you have a leak in your sample delivery system, or perhaps inside the unit, one way you can tell that is by reducing the flow. And you can see now I'm reducing the flow. And if the reading goes up with lower flow, and the reading goes down with higher flow, in many cases that's a leak, and that's really useful for checking out your 3020T analyzer to make sure you've got a tight system. So if you are seeing reading variations, that's the first test you want to do, is the flow sensitivity test. Okay, but we check all these units for that type of test here before we ship it, so typically that's not a problem with the units, but it can happen if you're connecting tubing. Some customers want to connect plastic tubing to the unit. For a trace unit, we do not recommend that. You should use stainless steel tubing at all times, and good tight fittings, swage lock or equivalent, those type of things. In any case, now we can see we are on the 25% range, and we're going to go ahead and show you how to operate the unit now. The first thing you do is you want to go in and hit the enter key, which is going to bring up the various menus. Okay? So actually I moved a little too quick there. Okay, so the first thing that comes up is span. Now you see here, span. Oop, went a little too quick. Okay, now we have the choice between manual or automatic span. Manual span means you determine when the reading's stable. Automatic auto means the computer determines when it's stable. I prefer to use manual, so I'm going to go ahead and do that. I'm going to push enter. And now that's the span concentration, which is 20.9, which is a concentration that we have in open air. You see it reads 20.6. So we're going to go ahead and accept that, say yes. Now this tells you basically when the reading is stable. This is an indication, the slope value of when the reading's stable. So we go ahead and say yes. Now the slope went to 0. You don't have to wait for it 0, but it's a good indicator. So we go ahead and say now it's stable. And boom, done. Calibration done. Okay, this is that simple. And we would recommend, typically, people always ask how often you should calibrate. I typically recommend calibrating once a week or something like that, but the sensors are typically very stable. Some customers get by with once a month with no problem. Okay, so let's see the other features in here. Also, the other thing you can do is do a self-test. Now, if you have any question about the unit, you can go to the self-test mode. Notice what happens here. You select the menu option with the enter key, and then you accept it, and now it's running the self-test. To scroll up and down through the menus, you go through the up and down keys. Now what this is doing is testing the preamp, testing the outputs, testing the power supplies to make sure all of those are good. And this takes about how long does this take? About 3 or 4 minutes, something like that? It takes about that long. Well, in this case, it didn't take that long. Took very little time. So we have OK on all of the things. Power is OK, analog outputs are OK, and preamp OK. So we press any key to continue. Now let's scroll down for the additional menu options. In a trace analyzer, it will take longer to test because of the large capacitors on the preamp board. Okay. So here we go. Version. This tells you the software version. We already went through self-test. Log out is something you don't want to worry about. AutoCal, this is of interest to some people that want to set up auto calibration intervals. This equipment is available with auto calibration valves, so you can connect span, gas, and zero gas. And again, we don't recommend using zero gas most of the time, but so you can schedule, notice here, right now it says span off. That means there's no automatic span enabled, but you can go ahead and change that. Now I've enabled it, and you select the period, starting time, start from so many hours, every so many hours. But I won't go ahead and do that because there's no need to show that right now. But it's very simple to set up the auto calibration intervals. So we hit escape to go back, get out of that. Now we'll continue down through the menu selection. Of course, doesn't want to do that. We'll go back up. Okay, alarms. This is something everybody needs to know. To set up, oop, I missed it. Okay, enter. Now, you have two programmable alarms. These are fully programmable. So you can enter that. Now, you have the choice of the reading. Right now it's at 10%. If I want to adjust it, make it 7, I go down, using the down selection here till I get the level I want. I can say it's a high alarm or a low alarm. Notice I've changed it from high to low, back. I can defeat the alarm, which means the alarm isn't active no matter what happens. I can make it fail-safe or non-fail-safe, so that fail-safe means when the power goes off, the state of the alarm switches. So you see the power loss event. And latching means that even if the alarm condition goes away, the relay stays in that state until you unlatch it. So very straightforward, easy to configure the alarms any way you want them. These units actually are so easy to use that we get very little calls in customer support on the basic operation of these units, at least that I know of. We get more questions about how often should we calibrate and things, but don't be afraid to push these buttons. You can't hurt them. There's very little you can do to crash these computers. They're very robust. So feel free to play with them and those things. So again, this is the second alarm. It behaves this same exact way. And I think that is almost it. Oop. Oh yeah, the range. I don't think we talked about the range yet. Contrast is not something you need to worry about. Standby is non-active in this device. Range is the last thing. Now I mentioned you have 3 range settings. Right now we're set at 1, 5, and 10%. If I want to change that, I have can make it go up to 2, down to 3, whatever value I want. Notice we're changing that. We go over here, the medium range, we can spread it now 5, we can make that go down or up. Same with this. And over here we have the automatic feature. Now this is probably the most important part of it, which is we can program the analyzer to change range or fix on a particular range. So the automatic range switching, it'll change the range to be what it thinks is the best range at that time for operation. For instance, if you had a low range of 1% and a high range of 25, if your reading was 24, it would go to the 25% range automatically. If the reading was a half, it would go down to the 1% range automatically. Some customers like that, some don't. It doesn't affect the reading as it's displayed here at all. It'll give the same number regardless of what the range is, but it affects the analog outputs on the back. So here we fix the range high, which means it will always be on a high range, and we can do auto, we can fix low, or fix medium. And to accept that, you just hit enter, boom, you're done. So that's the basic configuration of the unit. What you'll see with the trace oxygen sensor is it will last typically 6 months to a year, and then suddenly over the course of a day its output will go high. So you may be reading a half a ppm for many months on your process, and all of a sudden come in that one day later and it's reading, say, 1.5 ppm or 2. In many cases, that is the sensor has expired. It'll time to exchange the sensor. That's how most of our customers know how to change the sensor. For a percent oxygen sensor, it has a different way that it malfunctions at the end of life, which is it just loses output. So all of a sudden you may be reading 20.9 or 10%, you come in, it's just reading 0. If it's reading 0 or erratically reading around 0, then it's time to change the sensor, especially if it's been 6 months or a year. Okay, so that's the basic operation. Removal of the sensor is the same as before. Declassify the area, pull out the sensor, dispose of it per your hazardous waste regulations. It's basically like a flashlight battery. It has lead in it and electrolyte solution, so it should be handled in most cases to disposed in the same safe way you would dispose of as a flashlight or battery for your camcorder or something like that. The other thing we want to talk about is maintenance. Now, generally speaking, these units require very little maintenance except the occasional replacement of the sensor. But in petrochemical applications, one wants to look for particularly buildup of water or debris. And so you want to occasionally inspect your sensor holder to make sure there's no signs of water and debris in there. But for air separation applications, generally speaking, there's no cleaning required at all. These boards will last typically many, many years and give good service. Occasionally there will be a circuit board malfunction after many years. The thing that would be most likely to malfunction in the unit would be the power supply. And you can tell if the power supply is bad by going through the diagnostic features, or the unit won't power up. If the unit won't turn on at all and you have AC power, that would be showing you it's probably a power supply. And again, the way to test for see what's going on is to go into the diagnostic features. We'll run through that one more time to just show you how to check for the power supply, as I mentioned. Go to the self-test feature, hit enter, boom. See, it's checking the power supply, testing the 3 power supplies. In this case, the power supply is good. So I hope that suffices for the basic training. We've covered the sensor installation. We've covered the basic theory of operation of the sensor. What it does is it produces a current that's linear to the amount of oxygen. In fact, one thing I can show you on that, if you have some question about whether your sensor is good or not, there's a very easy test to do. Very simple. Any electronic technician can do it. Is remove the sensor, expose it to air, put it down on a table, and then measure with a multimeter in ampere mode the current from that contact surface in the middle to the contact ring on the outside. And typically, for most Teledyne sensors like this, you should get between 200 to 600 microamps, 200 I should say, to 600 microamps in open air. And that'll tell you if your sensor's good or not. If you have some question, I'm not sure if my unit's bad or my sensor or what's going on. That can tell you in many cases. Now, I should caution you a little bit with a trace oxygen sensor. When it gets a higher output near zero, after 6 months or a year, it'll still put out that 500 microamps of current. So that maybe isn't the best test for that, but certainly for a percent micro fuel cell, it's an excellent test to see if it's still functioning. And I should caution you, if you're working on the unit, just be a little careful that there is hot AC here, but this is all DC voltages. What? Oh, no 4 to, yeah, this unit has no 4 to 20. Oh, that's peculiar. Should have some 4 to 20s. Huh? Oh, that's right. With that's a good point. My colleague again has mentioned, which is the P unit in some cases is ordered without 4 to 20 milliampere outputs. So that's what this one has. There's no 4 to 20s in it. That's an option, sales adding option. For the T units, it's one unit comes, for the percent of range comes standard, and if you want the range indicator, it's extra. This particular unit, as you can see, has no modules mounted here. These were the modules where the 4 to 20 milliamps go. So thank you for mentioning that. Okay, well, I hope that suffices for the training. Again, should there be any questions that come up, we'd be happy to make some additional documentation or come down and train you also in person. I hope you find this training video useful, and thank you for your patronage of Teledyne Analytical Instruments.